Hi guys, this is Thomas. Today I'll show you the first type of a Windows assembly application in Visual MASM. This will be a 32-bit Windows message box. We used the same type for our first Hello World application in a previous video. So I'll go in a little more detail this time and give you just an overview of some of the other application types which you will be able to watch in other videos. I hope this is helpful, and let's get started. So here you'll see the initial empty Visual MASM project layout. Normally you would see the welcome page like so. So what I'll do is, let's see, first let's save our project group up here into the common projects folder. Or actually, before we do that, I think I've already changed it. See, I already changed it to Visual MASM projects, our common project folder, or you can consider that a root folder. This is helpful when you want to use this common folder maybe to store all your project source files, all the artifacts that you have, everything, say, under GitHub, or any other source repository. To reset this, all you have to do is click here on this exclamation point, and it will reset it to the default installation path where Visual MASM is installed. But I wanted to install under Visual MASM projects, like so. And all future projects that we will be creating will be stored under this common project folder. So let's cancel this out. Let's double check. I think it's correct. Alright, so let's store the group itself into this folder. I've already stored it there. Okay, let's create a new one. Let's rename this. Let's try first group, and we'll store this like that under VM projects, first group. VMG stands for Visual MASM group file. It really just has a collection of all the projects and some group settings that Visual MASM will need to assemble and build all projects in a group. I might show you guys at a later point what that looks like. It's simply a text file in JSON format that you can actually change manually, but really there shouldn't be a need for you to do that. That's not correct, it doesn't exist, but I might have to look at that one. Okay, so we had our first group, empty group, and let's create our new project. I can either right click on the group itself and then add new project, or I can go to the file menu, new, and then pick one of the application types, like the 32-bit Windows message box application. I usually prefer to use the project manager for some reason. It's convenient. First type will do the message box here, and click OK. So what happens is Visual MASM will go ahead and take the template file in the templates folder for this type of application. You can modify this template yourself if you have a preference, of course. It doesn't have to be message box type. This is just really some assembly mnemonics and some very basic instructions for MASM to create the assembly program. Really, theoretically, I could add in this case, for example, I could add a dialog file or any other assembly file. It doesn't have to be just a message box file. It just gives you a head start with some of the basic settings here. Just to keep that in mind, it's not very strict. So if I right click on this project here, click options, you'll see the type is just determined here as a message box application, when it was created, etc. Where your output folder will be. Output folder would be any files that are assembled, meaning an assembly file will be created and then assembled into an OBJ, an object file, binary object file. Any other outputs, if you do a debug version of it, the debug symbols, etc., any other additional files, resource files will be placed in your output folder. And depending what type of output you would create, it's either a release version or a debug version of an application. Let me show you what that looks like. So it's either, if I right click here and run, it would generate a release version. So that output folder would have a new folder called release right underneath it. I'll show you that, what it looks like. If you create a debug version, go to run and then select run debug or Control Shift F9. And that should either create a run or a release or debug folder right below the project folder. All right, so let's just do this. Just press F9. First thing is going to prompt me to save my file, and it should save it under the common projects folder here, which is correct. I'll just save it and then save it for the assembly file, like so. I've already created this before, so it's going to override it. And then it executed it. Hello world. It worked. Let's take a closer look. Just to show you, Visual MASM by default turns off the copyright notice from the Microsoft Macro Assembler. So really what you only see here is this individual assembly file that's been assembled. This is the output from MASM. This up here is just a header from Visual MASM that shows you that it's assembling the project itself with the final output file. In this case, it's an executable. These few lines here are also generated by MASM. It tells you that's an ASCII build. It's the type of code page. And then what is the final output of it, which in this case would be an OBJ file, an object binary file, which is the binary representation of your assembly mnemonics up here, right? Of all your instructions that you that are converted into binary representations. And if there would have been any assembly errors, you would have seen them right between here, these lines. MASM would display where, the lines, the line number, and what type of error you would have. You'll see this, I'm sure, very soon. After that, after the assembly process is completed successfully, then Visual MASM will go ahead and start the linking, which means it will take the individual components, in this case the OBJ file, and create a final output, which is the executable. That's what we really want. And this down here is the output from the linker this time. And it says that it created a final output file, and then the size of it itself, it's just determined by Visual MASM. It's a little over 2.4 kilobytes. If everything was successful, you should see in the upper right corner, you should see the size in bytes. The source itself is the source file size, but the output is the binary file size. I kind of added this to, just for me, I was curious what the size is, size differences. I thought it would be helpful to display this. Doesn't hurt anything, but it's kind of useful, so I liked it, and so that's why I put it into the project manager. What's interesting is if you noticed, so this is what I mentioned earlier, the release folder here is created automatically for you under the project folder, because I simply pressed F9, which generates the release version. Doesn't shade debug information. If I want to create a debug version, do Control Shift F9, and I think it's working. Let's see. Okay, I have to fix that. Go to run and then click debug. I think it should work. Yeah, so there we go. It's the same application, but this time it generated the debug symbols. It simply told the MASM assembler to go ahead and generate the debug symbols for it. If you look at the size difference, there's quite a bit of difference, right? It's like 300 kilobytes in symbols, which if you go learn more about what that means, it's really helpful information for any debugger to determine where your instructions are located inside the source file. For example, the line numbers, where it would locate, so you can have a cross-reference between your source files and the executable on where it would be if you want to step through your your source code step by step. There's a bunch of other things in it, but just to know that it is larger, and it produces larger executables. In this case, 3.5 or 3.4 kilobytes or so. And so if I run this again, or press Control F9, there you go. Control F9 is just assembling, and then building without executing. I do this quite often, actually. I don't want to execute every single time. I just want to see if everything assembles and builds correctly. Okay, so that's the very basic steps on get you going with a message box type. What else can I show you? Maybe I can show you the structure of the group and the project file. I don't want to spend too much time, just to let you know that those are both text files maintained by Visual MASM. So let's go ahead and grab let's look inside the Explorer. Let's see if I can show you. If I look at this outside of Visual MASM, say I use Notepad, if you noticed here, it's the name of the group, the uniquely identified number that's generated by Visual MASM. Don't change those. When it was created, the time, date, and where the group itself is located, and which project is currently the selected one, and the last file that was opened. So it's very basic. And let's take a look at the project file. Let's show that here. Since I only have one file in it, you only see one file displayed. It is a Windows 32 application. There's about almost a dozen types now that I have put into Visual MASM. This is just an internal enumerator that I'm using to identify what type of project it is. But it tells, when you look at, right click here in options, here's the actual full description of the type. Sometimes that's helpful because you might have dozens of applications or dozens of projects within a group, and it's helpful to identify what type it is. And then within the project, it knows how many files are belonging to a project, the type of files it is. It could be assembly files, could be binary files, could be library files, DLLs, etc. Not DLLs, but the type of source it is. I think that's about it. Don't worry too much over these JSON files. It's simply a structure that I'm using internally. What's interesting is this is not really related to this first project type, but if you go to Tools and then Options and Themes, I don't have anything yet to allow you to change the colors and the syntax for every mnemonic, keyword, Win APIs, etc. But you can modify them outside of Visual MASM using a simple text editor or even Visual MASM itself. Load the file and then modify the text files according to the colors that you want. I just don't have time yet to create this. I'm working on more important things right now to make sure everything runs without any exceptions. And I still want to continue with the debugger that's built in and coming, hopefully, at some point. It's quite a complicated process, but in the meantime, you can modify the colors. Same concept, just like the groups and the projects. They're JSON files you can modify manually if you want to, if you don't like the current color settings. Just to let you know. One thing I want to show you is if you right on a project and then click Options, just to go through the steps, what that means. So, like I said, the output folder for a project file all goes in this particular one. The library path, if you set them for the project, Visual MASM will use it. The files you want to assemble, that means which files do you want to send to the Microsoft MASM assembler, and then let it do its job to assemble these source files. Sometimes you might add source files into a project just for reference, just to look. And I'll show you this in another future video. For example, how to add a file from Kip Irvine's book or from the MASM 32 SDK example projects, or from the Axelion tutorials that are online, very famous really for many years, how to take those files and then make them work in the Visual MASM environment. Sometimes, or many times, these projects or these files you get from an external source, they have their own batch files. You can use them, of course, but and Visual MASM does support batch files. You can add them in there, and it even supports syntax highlighting for batch files. You could do that too. But if you want to take advantage of Visual MASM and the shortcuts and the productivity that this IDE will give you, then it's probably better if you let Visual MASM handle the assemble process and the build process. Nevertheless, you can take full control over the process, so it doesn't limit you to get extra control if you want to. For example, you can add these additional command lines for anything that needs to be assembled before the project needs to be assembled. And if you want to take over exclusive the entire assemble process, all you have to do now here is add all the commands you want. So theoretically, you could take what's in the batch file, modify that, paste it in here, all the things you need to do to assemble a project. This is, of course, only if you want full control. So this is really nice. I haven't really used this anymore because I haven't seen really a need for this. So I want the IDE to take the grunt work for me, the boring stuff really. Post-assemble will be executed after all files have been assembled in a project. This is useful if you want to execute a batch file or another executable after the assemble process. During the linking, so the link process or the link events is the same idea. You can execute anything before the linking starts, like a batch or an executable. Then you can take over the entire exclusive linking process, which means everything will be ignored. You will have to take care of all the linking of all the files and all the dependencies yourself. Again, you can do this from an old batch file and figure it out. Okay, these are the files that I need and I want to link to. You can take full control here. If it's empty, Visual MASM takes over and takes the linking out of your hands, basically. Any switches you want to supply to the linker, you can list here, one switch per line. This is useful if you enable certain switches that you used to, say, in older batch files or processes that you used to have. You don't have to do that. I think all the switches that are required based on the project types, and this is why the project types are important for Visual MASM, so it knows to apply appropriate switches during the linking process. For example, there's a big difference between creating an executable or a DLL, right? There's quite a bit of difference, so it takes care of the details for you. Any additional files you want to link into it could be a resource file, graphics, like an icon file, or any strings you want to link into the into the final output. You can list them in here. And anything you want to execute after the linking is completed. This is the very last step before the executable is started and executed. All right, so this gives you a quick rundown on the project options. I think that's pretty much it. So since I don't have time really to create assembly tutorials yet, because I still think that first of all, I'm not an expert, right? So, but if Visual MASM is at a state including the debugger, I really would like to have the debugger finished as far as I can take it, so that it would be helpful, especially for beginners or even advanced assembly programmers, that the debugger is sometimes could be very, very helpful. By the way, so I don't know if I showed this in a previous video. Let's go tools, options. Yeah, debug. So if you enable the external debugger like a WinDebug, you can download debugging tools for Windows. WinDebug itself is really just a UI. Underneath it, it's using the debugging engine from Windows. Extremely powerful. Has everything a debug environment would need. However, there's other debuggers you can download for example, you can use the Ollie debug. It's been around for many years. The thing is, when you enable the external debugger, say debugging tools for Windows Debug, WinDebug, what will happen is it will, let me show you. Say I would do a run debug. So what would happen is it executed it here, right? And it created the symbols, everything for it. But since I don't have the debugging enabled right now to use an external debugger, it just executed the application. If you enable this here and give the path to the debugger with the output file here, which would be the executable, it will launch the external debugger for you and you can start debugging. So once I have the internal debugger enabled or working, then you wouldn't have to deal with this, or you could. It's your preference. So that you can launch an application in debug mode and then step through your assembly code one line at a time. So that's the ultimate, right? But it's a fairly complex process to put the debugger in it. So I'm still working on it. Anyways, just to give you a hint. So let's go a real quick overview of what this assembly code really does. The 386 directive is a MASM directive, and MASM itself has a ton of really helpful directives built in, and MASM itself is considered a macro assembler, and the macros themselves are very powerful and allows you to really save some of the repetitive work that you normally would have to do if you don't have any directives in an assembler. And if you notice, if I hover over with my mouse here, on the right side, you can see Contextsensitive Help being displayed. Let's make this a little bigger. Let's see, change the font to 12. Alright, it should be easier to read here. Like so. So you can read about it. The help that I have here is not complete. There's quite a bit of help missing still. I just didn't have time to type it all in. It's quite time consuming. But it gives you an idea, like the model directive, for example. It tells you the type of call you will be making. In this case, I set a 386, enable all the 386 instructions, set the 386 CPU. Many people enable really the 586 or later types, but for basic applications, the 386 would work. This means you will need an 386 CPU or later to run this assembly or this message box with Windows. If I type in 286 directive or the 8086 directive, of course, there's certain things wouldn't work anymore. The model directive shows you here on the help on the right what type of calls you will be making. This will take more time to explain, but just to let you know, you can leave this unchanged normally if you create new applications. In this case, I don't want case-sensitive source assembly code, so I'll turn the case map off. The include files are needed for simply because I'm using the calls to the Win APIs and the prototypes that are defined in MASM 32 SDK package. If you open up these files, you'll see all the prototypes that are required to make these API calls. This is like a standard set. There's a one-liner that you can use nowadays instead of those three. And I think I should update the template accordingly to make this simpler even. Then the libraries that you will need, those libraries are actually include the object files and the way for you to call the Win APIs directly. These are assembled when you install MASM 32 SDK. So it's most likely you'll use these all the time. I don't see why you would not use them. It's really core of Windows itself. The user 32 and the kernels are part of the very core of Windows programming. The data section simply is the way where you can define your variables. In this case, I have them statically defined here with null terminated string. Null termination means that a MASM would go haywire if the string is not null terminated. It simply will keep on going, and at some point it will crash or will make your system unstable, or I mean your application at least. The code section really is where all your assembly code will start. In this case, we just have a simple label, the start label. If you look in the lower right here, I have Visual MASM has the labels list and the functions list. If I double click here, let's put my cursor up here to the top. If I double click here, it will jump to the label directly, or you can right click on it and say go to label. It'll jump to you. This is really helpful later on as your assembly files will get larger. The functions are constantly in background being scanned, or the source files are scanned for functions that you create. So if I say test procedure, and then if you noticed on the lower right here, it detected as procedure defined. If I double click it, it will jump to the top of the function. So this is really cool and helpful as you create your functions. I keep saying functions, it should be called procedures. Yeah, so the start determines where your entry point is in your application. MASM takes care of the actual mnemonics for the details of the entry point. Invoke means it's equivalent to a call, but invoke is very time saving, so to speak, because if you don't use invoke, you would have to use call, and the prototypes manually defined. So invoke very nicely that will check the parameters for this WinAPI call, which is defined in the prototype, and then the parameters themselves. If I do Control-Shift-Space, you'll see I have tooltips here available for the parameters based on the WinAPI. If I say invoke something like that and press Control-Space, it shows me a list of options that I have available as I type. So if I say message box, like so, and it will help you to complete or do code complete much easier this way. One other thing I want to show you is you can press F1 if there's a Windows API that you don't remember, and there's over 30,000 with Windows 10. I'm running this on Windows 10, but you can run this on Windows XP. Visual MASM will run on Windows XP and higher. If I press F1, you'll get the help for this Windows API call. Like so, press F1. I'm not sure if I showed you guys in the first Hello World program how to get help, but if you run this, the programmer's guide, it will show you the MASM programmer's guide. I highly recommend you go through this. It tells you a lot of good information, very helpful. Get to know MASM really well. It's a very, very powerful assembler. In my opinion, the most powerful assembler that really exists. It was published in 1981. So for 36 years, Microsoft has poured its resources and financial support, and it's still updated every time Windows is updated. So MASM itself ships with the latest SDK. It ships with Visual Studio, usually bundled with a C++ option, or C++ Visual Studio editions, and it continues to be updated. It is part of core Windows, so if anybody tells you it's outdated, it's old, or it's not true at all. It's always what has been updated. I think it's at version 15 or 14 now, I don't remember. But the version that I'm using here with MASM 32 SDK, it's version 6.1 something, I don't remember. But it's completely valid. So you can run 32-bit applications, you can create them. There's even a 60-bit version in progress for MASM 32 SDK. Still work in progress. You can download, of course, the 64-bit version for Microsoft directly with the Windows SDK, the ISO image, the setup wizard, as I've shown you in the setup process. You can get that. Anyway, so this was a really longer video than I wanted to show you, but this is the first Hello World application using the message box application type. In the other videos, I'll continue to show you the different project types and what are the cool features and why you would use them. Hope you liked it, and see you next time. Cheers.